Okay, welcome back to session 2, and we will actually start directly in kind of finding more knowledge about this great topic of the Internet of Things. There's a lot of terms around it, and I mentioned last time already that cloud computing is a big part of what is going on in the Internet of Things. And however, it's something very confusing pretty often if I work with people about it, because the levels of abstraction, the levels of hierarchy are kind of mixing up all the time. So to get rid of these problems once and for all in the beginning, I want to make this little exercise where you educate yourself about cloud, edge, and fog computing. And recently, there was another term people dropped on me, which was swarm computing. And yeah, so just if you read about fog computing, also try to enter swarm, because depending on where you look, it's the same. Depending on where you look, it's something completely different. But I think it's important that you can make this difference. So I want you to basically study 10 minutes on Google, Wikipedia, or any of your search engine of your choice, the 3 terms cloud, edge, and fog in relation to the Internet of Things. And you might have to enter cloud computing, edge computing, fog computing to find more relevant results. So 10 minutes, then 5 minutes together with your neighbor, and then we will spend another 10 minutes all together in kind of coming up with something nice at the board, which might be a nice graphic to put this all into context. Your turn. Okay, let's take this in front. So who of you have found a cool example where it's really clear what the difference between the 3 is? Anybody found an example where they thought was easy to understand what is, in this example, cloud computing, edge computing, and fog computing?
Online storage.
And online storage. What kind of just about data, or in combination with some logistics, or elaborate a little bit more? What online storage?
Like data, for example, Google Drive.
Google Drive. Okay. So what is in this case the fog, and what is the edge?
Just thought about the cloud.
For the cloud. For the cloud, online storage is definitely a good example. But okay, let's kind of take it further. Is there, in this context, could we talk about the edge and the fog here in this context?
Yeah, probably if you have something like a cloud for your company,
Yeah.
and you're out in the field and collect data, and if it's an edge computing system, then you send them from your devices directly to the server.
Mm-hmm. So let's assume I like this example and the combination of the two. So let's say you are some kind of, let's say you grow wine. Yeah. So say you are a wine grower, and of course you have all the data of your grapes and all the stuff and logistics and warehouse stuff somewhere in the cloud on some cloud storage server. But you're now in the field, and you're kind of one of these fancy grape supervisors. So this does actually exist. So there is a job. So if you're a vineyard and you want to do some new grapes, you get some kind of tech guy in who kind of installs devices on your grapes, and lets these devices monitor kind of water consumption and temperature and moisture in the ground, and then eventually has a drone and can fly the drone over your vineyard and looks at some kind of weird coloration, and then and I think it's a good example where we can now show where is here the cloud, where is the fog, where is the edge. So what would be in this vineyard example, what would be the fog?
Yeah, all the instruments that measure our grapes or something else, they all send data to a mini data center out in the field, which then sends the data to our server in the company itself.
Okay, so How would you think that is set up? This is correct. So we have somewhere.
We have our farmhouse with the central data center.
Yeah. So we have somehow kind of here we have the vineyard, and so we have some sensors here in the ground. So that is a soil sensor. Then we have somewhere connected here some temperature sensors. And then we have some kind of drones flying around. Which have a camera, and yeah, okay, so, and we all agree that's fog, yeah? Or the swarm, yeah? So when we talk about swarm, has anybody found a different definition of swarm, like the number of devices which do the actual measurement? Has somebody found something else on swarm?
Decentralized computing.
Yes. And this is kind of the first time I heard about the swarm. I also thought about what you have read. So for me, that is very confusing. I think depending on how far you go, it means still the same. They say, okay, in the swarm, we can also do a little bit of computing, and that gives us independence. So depending on how we draw our architecture, these two things could become the same, but I think normally they aren't. Okay. So you said, okay, there's a mini local data center, yeah? So we have something here with some antennas, which in a wireless way can receive all that data, yeah? Yeah, I'm sorry, but it's not architecture, it's not an arts piece what we are doing here. So this is our, how would we call that? So if this is the fog here, it's the edge. This is your edge device. Why is it the edge?
Because it's geographically closer to the main network.
Yes, and no, it's basically on the edge where it finally goes into the internet. Yeah. So that's why, because it's the computer which is closest to all these little devices here. So did you find another name for an edge device? So we also call it very often a gateway or router, yeah? Or smart router. So if this thing is just sending all the stuff, what these devices measure here, directly to a server in the cloud, is it still the edge? So if this is just a Wi-Fi router, yeah? Just a gateway, can we still talk about edge computing in that case? No. Why not?
Because it has to make the weil es was machen muss, also die Rechnung anstellen muss in dem Bereich und dann wieder zurückschicken muss zu den Sensoren.
Exactly, because there's, apart from sending, well, you could argue, but you basically only transfer data over it. And from a logical perspective, there is a direct connection from the fog device to something in the internet, a cloud device, yeah? So if these talk directly and actually also receive commands directly from there, we have a very flat architecture. So we have only cloud and only fog. Why are we talking actually about fog? Why is that such a stupid word?
Because if we have too many devices, we can't see through our amount of devices.
Okay.
Something like a fog of devices.
Yes. But I think it has also something to do with the fact that this other thing is called cloud. Anybody found something?
Clouds are far away, the fog is close or around you.
This is a new one. I really like that one, but I didn't know that one. Very good find.
Because the fog is near the ground.
It's near the ground. This guy, I actually never thought about it. I actually thought, okay, the fog is kind of on the edge of the cloud. The closer you come to the cloud, the more it looks like fog. And but okay, I think all of these definitions are really cool. But it's again about water. It's about particles of water, and I think they wanted to make make an analog definition to what we already have. So we have this metaphor of the cloud, and then they wanted to have a metaphor of a lot of small particles. So and if you look at fog, it's a lot of small water particles, and so this idea of fog captures a little bit the size of the devices in there. The cloud itself is something big, amorph, but the fog are these little particles. You might have heard of the company particle, which is one of the leading IoT infrastructure companies in the US at the moment. And so this is kind of the same idea, what we see here. And again, the edge is in between. But why is this concept of these three things so important? So has everybody of you always found these three terms? But we already said, okay, we have seen that we can easily ignore the edge and talk directly to the cloud. So why do people suddenly start talking about the edge? Why is the edge becoming more and more important?
Because the delay to send the information from the fog to the cloud is too long.
So there's latency is one issue. Or bandwidth. What else? Big thing. So we just say, hey Google, hey Amazon, your solution that we put everything into the cloud is the greatest ever. Yeah? So we don't need the edge because every device can just talk directly with the internet, with your servers. If everybody does that, the architecture is easy and the world is good.
But if it fails the connection, you have a big problem because like autonomous vehicles, they just crash last time.
Yeah, so if this connection here fails, we have an issue. What is if this here is compromised? The cloud. What if this is controlled by a hacker? What does that mean? So if you don't have this, if you don't have an edge, and our cloud resources are compromised.
You lose the whole control about fog.
Yeah, not only can they get the data, but they might be able to trigger actions over there. Yeah, so imagine that's not a vineyard, imagine that's a nuclear power plant. Maybe not the smartest idea to put it directly into the cloud. Maybe even one gateway is not a very smart idea. Maybe you want to have several layers, or maybe not a connection to the cloud at all, or just an internal cloud, a hybrid cloud or so. So these borders and layers are extremely important, and often it's not only 3 layers. We might have several maybe several cascaded edge devices. So that can make sense in terms of bandwidth, computing power, latency, security, and another super big topic, privacy. So yes, I think, I don't know, does anybody of you have an home automation system at home? Is anybody of you using Alexa or Google Home? No, not yet? Okay. But people who are basically have the architecture, everything in the cloud, and everything is connected just through the router into the cloud. So basically, we have the same problems as we say. You cannot switch your light anymore by voice when the internet is off. So there might be some local connection that you can still have your light switch, and your light switch still can actually turn on and off your light. But you cannot say anymore, Alexa, turn on all lights. Because it will say, hey, I'm not connected to the internet. Also, Amazon knows all your habits. How warm it is, when you come home, when you are home, when you use your bathroom, when you, everything. Yeah, your voice, what is said, listens to everything you say in your house. I know most people think that's okay, but I think if we take that out of the home context into an industrial context, I think it becomes very, very fast clear that you don't want that. You do want voice assistants. I think voice assistants is a really cool invention and can not only be used for switching on your light, but could also be used to help you with your industrial work and design work and these kind of things. But being aware where these layers are, if we talk about the cloud, if we talk about something which can be done on the edge, if we talk about all the fog devices, is very important. However, it's not completely clear. The device in the drone here with a video stream, there might be something edgy going on the drone, yeah? Because it's a relatively powerful computer already. And it might make a lot of sense. So there are a lot of startups at the moment kind of building drones for supervising power lines or gas lines. And it would be stupid to send, I don't know, a gigabyte per second of video data to a cloud, process it there, and then send it back to the drone while the drone has recorded another 20 gigabyte of data. So what you want to do is you put a powerful graphic card or some kind of multiprocessor onto the drone and do a lot of post-processing right on the drone before it's sent to all the gateways on the way. And even then, so if you have 50 drones flying, this might have to be further computed down before a reaction is triggered. So the whole exercise here is to make you aware about these different levels. Yeah, so when we continue talking about gateways, smart gateways, fog devices, and the cloud, then I want you to, that this image kind of comes in your head. So when we talk in our class about this, we will talk, I think when we talk about the cloud and cloud resources, we all have the same understanding. I will talk a lot about gateways. So when you hear me talking about gateways, think edge. Yeah? So our Raspberry Pi, what we have is the smart router. You will do some more stuff with the Raspberry Pi later on the Raspberry Pi, which we can call edge computing. Then the ESPs, I will usually call nodes. Yeah? And what we connect, the actors and sensors, we connect to it, I will call the devices. It's not completely clear in that way when I speak if the ESP is actually an edge device or a fog device. I think usually we can assume the ESP is a fog device. But depending on how much intelligence we put in there, we will do that later. We will kind of do some short circuits where when you push a button on the device that also something is triggered directly. That's more edge, yeah? But I want you to know these separations. Good, thanks. Hope I drove that home. You can stop the video. So, I have another little exercise for you. We will work a lot with these devices that are connected to our fog/edge endpoints. So it doesn't need to be wireless what is going on there in the fog. Yeah, if we, you have used cables to connect the button already to the ESP. We will do other devices today, so that you know how these devices communicate. We will look at the very, very basic buses we are going to use here. Who of you has heard of RS-232? Okay. Oh God, this is such a young generation that don't even need this. Because when I grew up, that was all we used, was RS-232. Terminals and this kind of stuff. That's all that other stuff is really advanced stuff here for me. So maybe I did something with RS-485. So the funny thing is RS-485 is actually something designed by the same consortium we've just watched the IoT video about. Now the same guys who made that video designed the standard RS-485. Who has heard of RS-485? Nobody? Nobody of you works in kind of music with lights and kind of some cool stuff? No? Or anybody of you wants to work with a power plant at one point or has some solar panels on the roof? You will be exposed to RS-485. So I2C. Yeah? Good, good. So some of you have worked with Arduino. SPI. Same people who know I2C. Have you heard about one wire? Apart from me mentioning in the last lecture? Good. So what we will do now, I will just count you guys through, and depending on the number you get, you will do the research on that protocol, and then we will zigzag this information back together. So, you are number 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Start here again. So we move 1, 2, 3, 4, 5. 1, 2, 3. So we will continue. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Yeah? So if you're 1, you do a little research, 10 minutes on RS-232. If you're 2, you do a little research on RS-485. If you're 3, I2C, 4, SPI, 5, one wire. So again, find examples, find devices which use that. Find context, scenarios where that is used. Also, figure out how the wiring is, find a kind of sketch, kind of schematics, how it shows how many wires you actually have to use. Find something about speed, how much data can you actually send over it. Find something about normal and maximum lengths, so how long can we make the wires. Maybe how many devices can you connect. And again, find good scenarios for it. After 10 minutes, you will meet up with all the people in your group. Yeah, all 1s, all 2s, all 3s, all 4s, all 5. Yeah, and then you will share your information. And after that, we will shuffle around and let everybody present to respective peers. So we will find a group so that we have 1 from each in the group, and you will present to each other. Go! 10 minutes research, then we will need about 20 to 30 minutes to share the results. Okay, let's make a small break. I have to show you something else. I will try to do that in 5 minutes, and then we have the rest of the time for actually working on sharing the results. I have already kind of insisted a lot on examples here in this lecture. And that has to do with that some of my research area deals with software development based on scenarios and examples. I've written a textbook for software engineering for making requirements engineering and object-oriented programming easier. And this book is called Story-Driven Modeling. And it's all about being agile and very close to the customer and creative and also critical about the whole process. And the same way of thinking I want you to develop here in this class, because in the end you should make your own project, and that should be based on these principles. So the issue is I get sometimes very weird solutions from students if I ask them to come up with an idea, and so they're usually not concrete enough for me. So last time I did the home and building automation, the student suggested to me they want to do a big house, something with Airbnb, a smart lock, and more automation. And I said, yeah, that's a very nice idea, but I would like to know a little bit more about that. So then they came back to me and said, okay, so our idea is that there's a landlord, has a house with multiple bedrooms, and offers these rooms on Airbnb. Each room is supposed to have a smart lock, air conditioning and temperature control, temperature sensor, and an automated media system. This should all be controllable via a phone. I said, great, that's much more information. It's pretty good, but I want even more. So what I want is kind of a complete pitch, so something you could play. Yeah? So if I ask you for an example or a story, I want something like this. Yeah? So we have a title, so Airbnb home automation, smart lock, noise, temperature, scenario. So we have the participants, so that you know how many people you need to make your little pitch. So you have the landlord, who is called Kali, and we have the tenants, Bob and Eddie. So Kali has a house in Linz, Austria, so we give all the specifics, like where this is supposed to happen, with 4 bedrooms and rents out 3 on Airbnb. He's currently on a small hiking trip in the forest nearby Linz. This summer, the outer temperature is around 30 degrees Celsius. Eddie stays already in his room and is binge-watching Game of Thrones. Kali's cell phone rings, and you see there's some information where you can argue maybe that's too much. But I rather want you to go to this point where it's too much, where it's very picturesque, than to be not concrete enough. Kali's cell phone rings. It's his new tenant, Bob, who's just arrived to his house and wants to enter. However, the main door is locked. Kali opens his house management app and activates Bob's profile. Bob logs into Kali's public Airbnb Wi-Fi, as he doesn't have a data plan in Austria using previously exchanged credentials. He opens the Kali's house app Kali made him download earlier and presses the open main entrance door button, which unlocks it. Bob can now enter. Bob finds his private bedroom, and so on. You see, it's kind of a step-by-step things, and you could imagine the persons who are in here playing that. And it's a little bit this idea that you can go in the end and have a video or some presentation for Shark Tank and kind of turn the whole thing, what we are doing here, into a business idea. Yeah, so when you develop software and scenarios in my class, I want you to potentially be able to pitch that in the end to an investor. And the investor wants something like that. And the story-driven modeling software engineering guy wants exactly that too. So there's a big part in agile software development where they want exactly that as their requirements document. But the nice thing is, a nice side effect it has, it makes you more creative. In the beginning, you think that it's really annoying to work this way, but after a short time, we'll start come with really nice, creative new ideas, and maybe even start enjoying that way of working. Okay, because today in the lab, you will do a little bit of that. This is why I had to tell you that now. We can now go back to what you have been doing before. This has other advantages. I don't have to tell you this, but you will see here one of the part of the lab today is actually to research a scenario. I give you 3 titles, and you can pick and do some stuff with this. And then in the end, as homework, until next week, you will elaborate on this scenario. In addition, in the lab, you will today extend your button to a smart button, which is connected to the internet. So we'll take the cloud in the lab to it. So we'll do something where you can push a button and get a message on your phone or on Telegram. And you want to learn how to use I2C today And so you get a display you can use to experiment with, and you will learn how to use one wire. And all of this needs to be connected to Wi-Fi. Let's go back to this, and we can burn the rest of the time of the lecture to it. I would say let's meet 5 minutes with your peers. Group 1 meets over there. Group 2 in that corner, Group 3 in that corner, Group 4 in that corner, and Group 5 meets in the center or here in the front with me. Then 5 people there. Come together and really start quickly. We don't have much time. Try to stay in 3 to 4 minutes. We're just going through the points I have mentioned there. So I think 2 of you have to go to the backseat because I counted that way. Okay. Any favorites? As I mentioned, so I always told some groups that I2C is one of my favorite buses because it's low active. I don't know if you all figured or read about what low active is. So basically the 1 is ground. So it pulls the voltage level down. Usually we kind of have high active, so if the voltage is up, it's a 1. If the voltage is low, it's a 0. And with I2C, we have pull down or floating. And the cool thing about that is you can actually connect devices with different voltage levels together, which will turn out very important for some things we are doing in class. So that's why I like to work with I2C quite a bit. And it's pretty fast and very easy to wire. Anything else special you guys found which you think should be shared with everybody about these buses? I ordered 20 of the RS485 adapters so we can build our own real industrial devices because that's one of the most industrial buses in there. So, but I don't know if they arrived. So if we get them, we will actually build our own RS485 devices. And so if you do something in the area of power measurement, kind of solar panels and so on, you will always find the RS485 bus. So that's kind of what you find in really in automation a lot nowadays. If it's more in the area of home automation, all the other buses are very popular too, but it would be nice if we could actually do some work with RS485. I will see if we have the hardware and can actually work with it. Else, we can definitely do RS232. You will use that for debugging quite a lot in the class. Okay, thanks. Sorry, that's kind of a difficult exercise where we mesh lots of things together. I hope you kind of could enjoy it a little bit. Again, it was more for me for preparing you to use this stuff than to memorize all these things. So I hope you have an initial idea, and now you can go in actually doing the hardware after you have designed your first story. So I actually moved an exercise from the lecture into the lab, which is kind of building your first story. So first thing, you will pick one of the 3 topics we have here. So either you say you want to build a home gateway, so with a company designing home gateways. Of course, we need a much bigger story for that, an actual home. Then the second one would be you build a middle school emergency remote for schools against robberies. This is a case I took from Baltimore. There's a lot of crime at schools in Baltimore, and they asked us to design a case how we could actually build such a remote people could carry around. Of course, you have to describe the whole robbery case in there. And the third is more locally, so you have to record current wind and temperature data over all Upper Austria to allow decisions for wind farm management. Yeah, so if you want to position your windmills correctly, then you need a lot of weather data. You need to compare the local weather data with the one in the cloud to make the right predictions to position that stuff. So also there is a lot of story potential to do. Pick one you like, maybe ask your neighbor team that you don't pick the same story. Maybe it's more interesting if you have 2 different ones, but be a little crazy and creative and make a nice story of one of these. All of them have a lot of storytelling potential. And then you can play with toys again. Okay, thanks. See you in the lab.